Welcome. In today's video, we're going to talk about perpendicular form. So we're doing perpendicular form of equation of straight lines. Okay, so we're doing equation of straight line series, and in our previous videos, we have covered the other forms of equation of straight lines as well. Okay, so let me just do a little recap what you have covered in the previous videos. If you haven't watched them and you want to learn about them, then please go ahead and check out my other videos. So the first is y is equal to mx plus b. This is the slope-intercept form. The first form and the most important one we talked about in a first video. This is the double-intercept form, and then we talked about. Okay, so this is the point slope form, meaning when you have one point given and you know the slope. Okay, then this form is actually used. I'm not telling you in too much detail because I have to make the video, okay? This is 2 points form, okay? When you have 2 point given there, okay, 2 points that the line passes through, okay? Then you use this one. Okay, that was a little recap. Let's move on to our topic. So these 4 forms we talked about, this is the 5th form of equation of straight lines. So what does perpendicular form mean first? So you'll understand from the figure. So let me draw the figure first. So here it is our Cartesian plane, and there is a straight line. Okay, so I draw the straight line like this. So this is the straight line. It makes the x-intercept and the y-intercept. There could be situations where it doesn't make. One of the intercepts. Okay, either the y or x. Okay, when it makes only one intercept. Okay, but if you talk about this, it will be in the formula that we come up with will also be suitable for the situation when you have only one intercept given, meaning lines like this and this or this. Okay, if you're not getting it, you'll get it now. Okay, but let me explain. The formula that we will come up will also be suitable for this kind of line, or this is the Cartesian plane, or for this kind of line. Okay, so but let's derive the formula first. So this is the line here, and it says perpendicular form, meaning what you don't know about the line. What you know is that a perpendicular line is drawn from the origin to the line. Okay, so a perpendicular is drawn from the origin to the line, and it makes an angle alpha. Okay, so it makes an angle alpha, and the length of the perpendicular is p. So this is what you know. Okay, this thing is known. So the known thing is about the perpendicular line. That what angle it makes onto the x-axis. This is what you know. Okay, so let me recall this again. You know the length of the perpendicular line and the angle that it makes onto the x-axis. These things are known, and you'll be like, how can we derive the equation? Then think of this geometrically first. If you know the perpendicular, let's say the perpendicular goes like this, okay, and a line needs to be drawn which is perpendicular to this, okay, and then it will be called perpendicular. Okay, a line is to be drawn this, then that line is just one line, okay, which is perpendicular. If you can draw that line, okay, it specifies only one line, then it means that this much condition only enough. Okay, this much condition, the conditions that are given are enough to derive the equation of this line. Why? Because when you have just the length of the perpendicular and the angle that the perpendicular is at, okay, or the angle that it makes with the x-axis, if you're given only these conditions, then if you draw the line which is perpendicular to this, then it will be only one line. You can draw only one line, okay, specifically. So there will be only one line there drawn. If you can draw it, then you can derive this equation as well. Okay, if I can draw it, it means I can derive this equation as well. Okay, so let's move on. Okay, let's move on to the topic how you're going to derive this equation. Okay, one more thing that I want to make clear again. If you vary the inclination here, okay, that's it. If you vary the inclination, let's say the inclination goes like this. Okay, the angle changes, the angle has decreased. Then you can see the position of the perpendicular, because the perpendicular line is like this. Okay, so the position of this line also changes. In other words, the slope of the line also changes, meaning that it depends purely on the length of this and also the inclination of this. In the same fashion, if it changes length, again, the position of the line changes. Okay, so purely depends on the length of this perpendicular and also the angle that it makes. Okay, so these two things are affecting the line, meaning these two things will come in its equation. Okay, how do you derive it? We're gonna make this look familiar with our previous form of equations that we talked about. So what you're gonna do is you're gonna find this length first. Why are you gonna find this length? Because this is our x-intercept. And then we're gonna find this length here, this is the y-intercept. And when you know the x-intercept and the y-intercept, you're gonna use our same old formula. You're gonna use the same old formula to derive this equation because with the x-intercept and y-intercept, this is the equation, okay? So we're gonna use this formula to come up with a new formula. Okay, so let's derive the x and y-intercepts here. To derive the x-intercept, I'm gonna use this triangle here, okay? Because, you can do trigonometry here. You can use trig functions here, okay? We know the angle here, and we know this length, and we have to find this length here. Okay, so I'm writing n. So I'm gonna write n triangle. Let's name it. Let's say this is O, A, and this is B. So I'll name this later. Okay, let's do it now. Let's say this is C. So in triangle OAB. So in this triangle, what I'm gonna do is, what's gonna happen is that I want to find the relationship between this and this. So what trig function does that? So this is the adjacent, as you can see, because this is the longest side of this right angle triangle, and this is the longest side. This is the hypotenuse, okay? And this is going to be the adjacent, and this is the opposite, okay? So you need to first identify the sides, okay? This is the adjacent. This is the longest one, hypotenuse, and this is the opposite side, okay? So adjacent and hypotenuse, that's the cosine, okay? Because adjacent divided by the hypotenuse is cosine here, cosine of this angle, cosine alpha. So cosine alpha is equal to P over divided by A, okay? P over A. And A represents here what? The x-intercept. And what I'm looking for here is the x-intercept, meaning the x-intercept A will be P over cosine alpha. Okay, so this is going to be our x-intercept. Let's find out the y-intercept. And for finding the y-intercept, I'm going to use another, because I'm making this a little messy by doing boxes. So let's get rid of the boxes from here. Okay, so what I'm going to do here now is, I have to find the y-intercept, which is here. And to find the y-intercept, I'm going to use this triangle because I cannot use this triangle, okay? Because as you can see that there is no relationship, okay? So I have to use this triangle here, okay? So let's use this triangle. So this here is 90 degree, meaning right angle triangle here. And this is going to be 90 degree minus alpha. So let me write it here. 90 minus alpha. Okay, this is going to be 90 minus alpha. And I'm going to use this angle to derive the length of this. So I have, again, this is the adjacent and this is the hypotenuse because this is the longest side. So adjacent divided by hypotenuse is again cosine. So cosine, this is not of alpha, this is of 90 minus alpha. 90 minus alpha is going to be this divided by this, P over B. Okay, adjacent divided by hypotenuse. Okay, Ka. Okay, from SOHCAHTOA, you can remember. Okay, so the length of B is going to be P over cosine 90 degree minus alpha. And, okay, then write it again. I won't go too direct. Okay, from this, what B comes out to be is, it comes as, what will be here? P over, what is cosine 90 minus alpha? This is same as sine alpha. Now you can see the relationship between this and this. Okay, now you've seen the relationship. What is the relationship between this alpha and the length of this? Okay. So we came up with B, meaning the y-intercept. So now we have the x-intercept here and the y-intercept here. Okay, so I encourage you to note this down, okay, properly in your notebook. Pause the video and go and note this down because it is important to note it. So I have the x-intercept here and y-intercept here. So I'm going to go further now. So I'm going to wrap this up. And all that I will care about is the x-intercept and y-intercept, because that's the thing that we're looking for. So A, the x-intercept is p over cosine alpha. B, the y-intercept here. B, the y-intercept is p over sine alpha. This is p over cosine alpha. This is p over sine alpha. And why we derive the x-intercept and the y-intercept? I told you already, so that we could derive the equation using our old formula. This is the old formula that we already know. Okay, so what is A here? This thing is A, p over cosine alpha. What is B here? Everybody agrees till here that this is going to be this thing, alpha. Now this cosine will go above here. This will turn out to be x times cosine alpha. Okay, this will be y times sine alpha. And all divided by p. So all divided by p. What we did? A little bit of algebraic manipulation. Okay, so if you solve it, this cosine is going to be above there. Okay, so x times cosine alpha, this will be divided by p. The second will be divided by p, and this will go above here. Okay, so I can write this all divided by p is equal to 1. It means, okay, so we made a lot of progress, and that's the end. Okay, we've reached the end. This will be x cosine alpha plus y sine alpha is equal to p. And this is the equation. This is the equation of the straight line, perpendicular form. And one more thing that I forgot to mention. This is also known as normal form. Normal form. Okay. The perpendicular line is also known as normal. Okay. That's why it's also called normal form. So x cosine alpha plus y sine alpha. This is the main thing that you need to remember. Okay. This is the main thing that you need to remember. Okay. So note this down, these steps as well, these manipulations, and how I derive this formula. Note this down by pausing the video, and I'll go ahead further now. Okay, so this will be x cosine alpha plus y sine alpha is equal to p. Okay, this is our main thing, the equation that you need to remember.